Hello everyone. Thanks for the opportunity that given to us, and we would like to give our appreciation to organizing committee who has successfully held this international conference CITES 2020. Me, Dendi Adi Saputra, with Associate Professor Yugo Osaka and Associate Professor Takia Sujiguchi, and the head of Environmental Science Laboratory of Kanazawa University, Professor Akio Kodama, will present our paper with title Effect of Change in the Regeneration Temperature and the Regeneration Air Flow Velocity in the System Performance of the Solid Desiccant Air Conditioning System. Based on the data that released by International Energy Agency in the 2018, they said that more than tripling of the energy is used for air conditioning system between the 1990 until 2016. This condition will affect to increase the installation of air conditioning system around the world. Notes in the 2016, around 1.6 billion air conditioning systems were installed. If we see who is the countries that have used a large air conditioning system around the world, China is the largest one user of air conditioning system, followed by the countries in the North America and the countries in Asia, excluding China and Japan. So this the behavior, the using of air conditioning system with use the vapor compressor system will result the bad effect. One of them is CO2. More than 1,000 million tons, or similar with the total emission of Japan, have been resulted, and around 2,000 terawatt hour of electricity were consumed when we operating the air conditioning system, or 2.5 times of the total electricity use of Africa. So based on this fact, we try and we propose the solid desiccant air conditioning system as the one alternative to substitute the air conditioning system with using vapor compression system. If we can see in this figure, the processed air will enter to the rotor. Rotor will attract some moisture that come to the rotor, and when the offset from the rotor, the processed air will be dry. The dry air will easier and consume lowest energy to reduce this temperature using the cooling unit device such as the sensible heat exchanger or cooling coil or evaporating cooler. To maintain the performance of the desiccant wheel, we need to maintain the rotor condition can capture the moisture for the process air. So the rotor need to regenerate again. So for the regenerate the rotor, we need the hot air. With heating the hot air, use the solar heat or waste heat is suitable to regenerate the rotor. And when the regenerated rotor is occurs in the system, the humid air will be transferred to the outside. And some researchers report that this technology was confirmed can reduce more than energy, maybe more than about the 45%. And also confirmed can reduce the CO2 emission because this technology not use the refrigerants as is the working fluid. However, this desiccant wheel technology still have some issue that must be solved. One of them is the system performance is still lower if we compare the existing solution that we found in the iconic system with using vapor compression system. So almost of investigator uh, find want to find which one is operating parameter that strongly affect or have correlation with the system performance of the second wheel. In this moment in our research, we try to investigate and we will take become a part of the investigate the operating parameter that will affect the performance of our desiccant. So we investigate the regeneration temperature and regeneration flow rate, and we want to examine which one is better between two operating mode operation. And we use this experimental apparatus consists of desiccant wheel, heater, blower, humidifier, and the air control box. And for the experimental condition, we set for the outside air is 15 gram per kilogram the air, and for regeneration air is 10.5 gram per kilogram the air. Meanwhile, for performance index, we use four performance index, and we use the mass conservation equation to validation to validate our experiment. Ladies and gentlemen, this slide tell about our result and discussion in the freeze operating mode, constant regeneration air temperature mode. As you can see in this figure, when the decrease of regeneration air velocity will decrease also the humidification performance and also system performance of solid desiccant air conditioning system. But in this point of the 1.25 meter per second until 0.83 meter per second, there are a significantly drop of the performance between the humidification performance of and the system performance. Is also shown in the recovery energy ratio in the side figure, uh, and the increase or decrease the recovery energy ratio with the decrease of regeneration velocity, and the effectiveness sensible of heat exchanger in this moment has a strongly affected by regeneration flow velocity. And then we can see the heat recovery correlation between the regeneration heat input and the cooling capacity is increased along as the increase of regeneration airflow velocity. And for the second operating mode, we maintain the regeneration airflow velocity constant of 2 meter per second, and we have variation of regeneration temperature start from the 46.4 degrees Celsius until 75 degrees Celsius. As you can see in this figure, during increasing the regeneration temperature also followed by increasing the dehumidification performance. However, the COP tend to decrease. Is also followed by recovery energy ratio. But in this operating mode, we found that this effectiveness sensible heat exchanger is not affected by change in the regeneration air temperature, and is have directly effect to the increase the cooling capacity of the system. We can see at the low regeneration temperature, the cooling capacity is more higher than regeneration heat input. That's why the COP at the low regeneration temperature is more higher than the high regeneration air temperature. So, yeah, we can conclude that the reduction in regeneration temperature and the regeneration air flow velocity is effect to the decrease in the humidifier performance. If we make comparison between two operating modes, we can see that in the viewpoint of the dehumidification performance, the constant regeneration temperature offer the better performance. However, in the side of the system performance and energy recovery ratio, the constant regeneration air velocity is have a higher value than the constant regeneration air temperature. So we suggest that if the dehumidification is our main priority in our system, it should be used as a constant regeneration air temperature. And for this in next investigation, we would like to investigate what happened in the system performance if we use this fluctuation in the regeneration heat input, and then we try to examine in our system and we evaluate performance with the thermal comfort condition. Thank you very much for your attention and thanks for the CITES 2020. See you and keep your health and don't forget to use the mask. See you for the next change. Bye.